Hello, dear aspirants. Let us answer this question, which was given in NPTCL Assistant Engineer 2022 paper. There are three elements. One is the resistor, another one is inductor, another one is capacitor connected in parallel. Resistor is having 40 ohms of resistance, and inductor is having inductive reactance of plus J10 ohms, and capacitor is having minus J10 ohms of capacitive reactance connected in parallel and connected to 200 volts 50 Hz frequency AC supply. So what they are asking in question is, what is the apparent power and reactive power which is supplied by this particular source to this particular network they are asking. Okay, so coming to the AC circuit, so we have three types of powers. One is the active power, another one is the reactive power, another one is the apparent power. So that particular apparent power is equal to the vector combination of active power and reactive power actually. Okay, so in order to find out the active power which is consumed by this particular circuit, so we'll use this particular formula, P is equal to V square by R. Okay, so only R element will be there in the active power formula because the active power is a type of power which is always consumed by the resistive elements. Okay, so that's why we'll use this particular formula. So by using this 200 whole square by 40, which will be is equal to 1000 watts of active power this particular circuit is consuming, and that is going into this particular resistive element. Coming to what is the equivalent reactive power which is consumed by this particular network. Okay, so let us solve that. This inductor is having plus J10 ohms, this capacitor is having minus J10 ohms, so both are having equal values. Okay, so that's why whenever in the circuit inductive reactance is equal to capacitor reactance is there, the equivalent reactive power which is supplied by the source will be equal to 0. Directly we can say the equivalent reactive power which is supplied by the source whenever the inductive reactance is equal to capacitive reactance equal to 0 we say. So that's why the answer, okay, so the active power is equal to 1000 watts and reactive power is equal to 0. Coming to the apparent power S is equal to P plus JQ. So that's why Q is equal to 0 means, okay, S is equal to P. That's why apparent power also we say 1000 volt amperes. Okay, so 1000 volt amperes of apparent power and reactive power is equal to 0. This is the answer. But conceptually, how to understand this particular reactive power concept? Okay, the reactive power actually the type of power which is consumed by the reactive elements. We have two types of reactive elements. One is the inductor, another one is the capacitor. Inductor is consuming the reactive power. So the type of reactive power, whatever it is consuming, will be called as lagging reactive power components. Okay, so that's why the inductor always consumes the lagging reactive power components and supplies leading reactive power components. Okay, consumes lagging reactive power, supplies leading reactive power. Coming to the capacitor also a type of reactive element which is also consuming a type of reactive power. So the type of reactive power which is consuming will be called as a leading reactive power components and supplies lagging reactive power components. Okay, so inductor consumes lagging reactive power components, capacitor supplies lagging reactive power components. Okay, so whatever the type of reactive power that particular inductor wants, that will be supplied by the capacitor and vice versa. Means whatever the reactive power that particular capacitor wants will be supplied by the inductor. Okay, mutually they'll transfer the power always. Okay, but in the system generally practically the inductive load will be more, capacitive load will be less. That's why always there will be some amount of the burden, reactive power burden will be there on the source. Okay, and that particular burden will be 0 on the source, reactive power burden will be 0 on the source whenever the inductive reactance is equal to capacitive reactance. Okay, mutually they are transferring the power, whatever the power they want. That's why the equivalent burden will be 0. Okay, so like that the equivalent reactive power which is supplied by the source in this particular question will be 0. That because the capacitor inductor strength both will be same. Okay, so that's what the answer here will be.